Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last few videos, I have discussed about SR latch using NOR gate and the NAND gate. I hope you have watched that videos. If you have not watched those videos, I request you to go back and watch those videos and come back to this video for better understanding. In this video, I want to discuss about SR flip-flop. So, I will discuss about its circuit diagram, its characteristic table, its characteristic equation, and also the excitation table. So, I request everyone to watch the complete video for better understanding. First, let me discuss its circuit diagram. If you see that I have constructed the SR flip-flop using the NAND gates. Now, if you look at this part is looking as a SR latch only. Am I right or wrong? Okay, using what? NAND gates. Now, as I said, we have 4 NAND gates. S and R, the set and reset. We have a clock connected to this NAND gate. So, these two NAND gates, one input is acting as a clock. Okay, are you able to follow it or not? Then we have the Qn and Qn complement. Don't think that they are two different variables. Qn and its complement. If it is 1, this is 0. If this is 0, this is 1. Am I right or wrong? So, totally we have 3 inputs S, R and Qn, and we want to find the next state, which is Qn plus 1. Now let me draw its characteristic table. In its characteristic table, we will have inputs which are S, R and the Qn which is present state. And I want to find the output which is Qn plus 1 which is the next state. Now if you tell me, if I have 3 binary variables, then how many combinations of inputs I will get? 8 combinations I will get. What are they? 0, 0, 0, 0, 0, 1. Then we will have 0, 1, 0, 0, 1, 1. Similarly, I will have another 4 combinations as 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Am I right or wrong? So, totally we got the 8 combinations where S and R is 0, 0, 0, 1, 1, 0, 1, 1, and each case Qn is either 0 or 1. Am I right or wrong? Now what we will do is that we will give the S value and R value for this circuit and we will verify what will be the output. So first one I will do, S value is 0, R value is 0 and the clock is 1. Am I right or wrong? Now look at it, what will happen. Now, if you see that this input, we have the Qn plus 1. We want to find the Qn plus 1. Check it, what is happening. Qn plus 1 is equal to, first what is happening? 0 and 1. What it will produce? Look at it. 0, 1. What is the AND gate will produce? If both the inputs are high, then only the AND gate will produce the output as 1. Whereas, if one of the input is low or both the inputs are low, then the AND gate will produce the output as 0. Now, but this is a NAND gate. What is NAND gate? AND gate complement. So, 0's complement will be 1. Okay. So, 0 and 1, this gate will produce the output as 1. Are you following it with me or not? This one will be the 1, which is an output which is acting as a one of the input for this NAND gate. Similarly, 0 and 1, this will also produce the output as 1. Now tell me, 1 and Qn complement, whole complement. Am I right or wrong? Are you following with me or not? Because I want to find the Qn plus 1, which is equal to 1 and Qn complement, whole complement, which is equal to Qn complement, which is equal to Qn. Qn plus 1, I got Qn. Now I will see Qn plus 1 complement what will happen, which is equal to, I got one input as 1, another input is Qn. So 1 and Qn complement, which is equal to Qn complement. Now tell me what is happening. Qn plus 1 is producing Qn. Qn plus 1 complement is producing its complement, Qn complement. So what I can say, the next state is equal to the present state. Qn plus 1 is equal to the present state. Okay. So whatever the present state is, the next state also will have the same output where there is no change. Are you following with me or not? Now we will see when S and R values are 0 and 1, what will happen. Can I erase this one? I request everyone to please note down the points what I am discussing. Okay, we have S value as 0, R value is 1. Now we will look at it, what will be the outputs here. If it is 0 and 1, NAND gate will produce output as 1. 1 and 1, NAND gate will produce the output as 0. Okay, now we will look at Qn plus 1 will happen what? Okay, 1 Qn complement whole complement is equal to Qn complement whole complement is Qn. So Qn plus 1 is producing Qn. We will see Qn plus 1 complement what it is producing, which is producing 0 and Qn whole complement. 0 and something will be 0, whole complement is 1. Now if you look at it, Qn plus 1 complement is producing 1, then Qn plus 1 is what? 1's complement. It is 0. Are you able to understand? So Qn plus 1 will produce 0 and its complement is producing 1. So whatever the Qn value will be, next state will produce 0. So this state we will call it as reset. I hope you are following with me, because Qn plus 1 complement is producing 1, then its complement, 1's complement 0 it will produce. Okay. Now we will look at when S and R values are 1 and 0, what will happen. If S value is 1, R value is 0. Okay, then what is the output I will get here? 0. And what I will get here? 1. Okay, now we will discuss it. Qn plus 1, what will happen? Qn plus 1 is equal to 0 and Qn complement whole complement is equal to 0's complement is equal to 1. Now Qn plus 1 complement what it is giving, which is equal to 1 and Qn whole complement. Why I am keeping the complement? 1 and this is NAND gate. So that's why I am keeping the complement, which is equal to Qn complement. Are you able to follow with me or not? Now you look at Qn plus 1 is producing 1. Qn plus 1 complement is producing Qn complement, which is 0. It is valid or not? It is valid. So always the next state is equal to 1, whatever the previous state it is. When S and R is 1 and 0, the previous state is 0, but the next state will be 1 and 1. So this state we will call it as set. I hope you are following with me. If you have a doubt, you can substitute 0 and 0. In Qn, you take the each case 0. If this is 0, this will be 1. You substitute the values. You find it what you will get the output. Are you able to follow with me or not? If you have a doubt, S and R value, let's take that 0 and 0. You substitute these values. And Qn, take this case. Qn is 0. Substitute 0 here. And this will be what? 1. Substitute the values and check what will be the next state. Okay, like that also you can do, but it will take more time. So that's why I'm discussing in a simple way. Now look at what is the S and R values will be 1 and 1. Okay. Now we will see if it is 1 and 1, I will get the 0 here. I will get the 0 here. Okay. So now we will see Qn plus 1 is equal to what? 0 and Qn complement whole complement is equal to 0 complement is equal to 1. Now Qn plus 1 complement is equal to again 0 and Qn complement is equal to 0 complement is equal to 1. Now if you look at it, Qn plus 1 is producing 1. Similarly, Qn plus 1 complement is also producing 1. This is invalid. Why? If this is producing 1, this should have produced the 0. Am I right or wrong? But both are producing 1, but they should be produce the complement output. So this one we will call it as a invalid. So it does not bother about these outputs. Are you able to understand it or not? So I hope you have got the how I got the characteristic table. When it is 0 0, there is no change. When it is 0 1, there is a reset. When there is a 1 0, it is set. When it is 1 1, it is invalid output. So we will represent using the don't care. We will not bother about that output. Now we will discuss the characteristic equation. Means I got the characteristic table. Now I want to find the characteristic equation. How I get the characteristic equation? I will simplify this expression. How I will simplify? By using the K-map. Now what I have to do? I have to find when this function is producing the outputs as 1. Here it is producing the output as 1. Similarly here, and these are the two don't cares because I am considering the min terms. If I am considering the max terms, then I would have considered the zeros and the don't cares. Now tell me how many input variables are there? 3 variables will be there, SR and Qn. Now tell me how many cells will be there in the K-map? 2 power 3, which is equal to 8. Am I right? If n variables are there, K-map will consist of 2 power n cells. Okay, let me find out those 8 cells. Okay, 1 2 3, then I have this one. I'll give S and R here. I think you already know about the K-map. Is it clear or not? Otherwise you can go and watch my previous videos where I have discussed about the K-maps. Now this will be what? 0 0 0 1 1 1 1 0. And this will be 0 1. Why I have written after 0 1 1 1? Because the adjacent cell should be differ by single bit only. If I keep 1 0, it will be differ by 2 bits. Okay. Now tell me one thing. When it got the output as 1, this one. So it is 0 0 1. First remember one thing. What is the sequence? SRQN. So SRQN should be there, which is 0 0 1. 0 0 1 means here. Then it is 1 0 0 1 0 0. Then 1 0 1 1 0 1. Then 1 1 0 1 1 0 is the don't care. Similarly 1 1 1 is the don't care. Okay. Now can you simplify using the K-map? How can we? First we have to identify the implicants. Now these 4 are adjacent. I can make it as a one implicant. Similarly this one, let me use another pen. This one and this one is adjacent. Am I right or wrong? If you have a doubt, you can verify it. What is this cell represents? 1 0 1. What is this cell represents? 0 0 1. Now if you look at these two are vary by only single bit. So if they are vary by single bit, I can say that they are adjacent. Am I right or wrong? Okay. Now if I got the two implicants, what will be the simplified equation? The simplified equation will be, first take the columns 1 1 1 0. What is common here? This one is common, which is equal to S. Okay, or this is the one min term I got, another min term will be. Now why I have not considered row? If you look at the row 0 and 1, nothing is common. Okay, so I got the one min term as S. Now I'll find the next min term. How many min terms I will get? How many implicants are there? Okay, or these two are the essential prime implicants. Am I right or wrong? Okay, now what will be the next one? It is 1 0, this is 0 0. Which is common? This 0 is common, which is equal to R complement. In the row side, it is 1, which is equal to Qn. So, Qn plus 1 can even written as S or R complement Qn. This is the characteristic equation of SR flip-flop. Okay, using this one also we can draw the circuit. Is it clear? So now let me discuss its excitation table of SR flip-flop, which will be useful whenever we are translating one flip-flop to another flip-flop. Let me discuss the excitation table. The excitation table will have the inputs as Qn and Qn plus 1, and then you have the S and R. Now if you have two inputs, how many combinations you will get? 0 0, 0 1, 1 0, 1 1. Am I right or wrong? Now if you look at it, what is the meaning? If Qn is 0 and Qn plus 1 is also 0, what will be the S and R values? Now you look at the combinations wherever it is having. This is one case, this is another case, am I right? Two cases are there. In this one, S and R values are 0 0, here it is 0 1. So what I can say? S value is always 0, R value is either 0 or 1. I can represent it as a don't care. Is it clear? It can be either 0 or 1. Okay? Are you able to follow with me or not? Now we will look at Qn is 0, Qn plus 1 is 1. So we need to find wherever 0 and 1 combinations are there. Can you tell me how many combinations are there? Only this combination. It is 0 0, 1 1, 0 0, 1 0, 0 1, 1 1. So I got only one combination. So S and R value is 1 and 0. Okay. Now we will look at 1 0 combination. Wherever 1 0 is there, this is the only one combination. Am I right or wrong? So which is equal to 0 1. I will substitute it. Now I will see the next one 1 1. This is 1 and this is 1. In this case, S and R values are 0 0, and this case it is 1 0. So it is don't care and then 0. So this is the excitation table of the SR flip-flop. Okay, I hope you have understood the SR flip-flop circuit diagram using the Nand gates. Okay, its characteristic table, characteristic equation and the excitation table. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.